Hello and welcome to another video. This has just been sent to me by a student called May. So hello May, and here's my efforts at these questions. They look quite interesting actually. A couple of mechanics questions, so good for you for looking at mechanics and maybe stats, maybe not stats, before the, even though pure is coming up first. It's important not to forget these. The hardest paper really is the applied, if you ask me. Okay, so projectiles with vectors. Now, I like projectiles with vectors. Actually, all projectiles questions I do with vectors. It said the initial velocity is 912, so I'm going to write u equals 912, yeah? Now, you may do it, with your arrows. I can see in your working arrows like that and arrows like that. That's no problem at all. Just remember, basically, I'm writing down lefty righties at the top and the uppy downies below. That's all I'm doing. I find it an easier way to include all the information. Now, we always get 0 acceleration in the x direction. But 9.8 meters per second down squared, 9.8 meters per second squared down, that's what that is. And then what else do we know? We know the velocity at any time is lambda I minus j. So I'm going to write that, v equals lambda. Let's times the lambda into this, so we can see it's actually lambda minus lambda. It's just saying basically they're looking for the time at which, I'll tell you exactly what it's saying, they're looking for the time at which the direction the ball is travelling is across and down with the same component. In other words, it will be going precisely at the path on the point on the journey where it's at 45 degrees. That's what it's saying when it tells me the velocity is that. Yeah, I don't know the size of it, so I don't know how fast it's going, but I do know the direction is the same amount down as it's going across, and as the velocity is like the tangent on the path that the object travels on. Well, the velocity is always the direction the thing's travelling in. I know it's travelling basically at 45-degree angle to the ground. But there we go, just thought I'd mention that. And S is, well, I don't really know the X component, how far we are along, so I'm just going to call it SX, which is what I often do, and SY if I didn't know the Y component, but I do know the Y component because they're calling it H, and I've got to find the value of H. So I look at these and I think, okay, I've got U, V, A and S, so I guess it's V squared equals U squared plus 2AS. I guess that's what I'm going to be using. And I'm going to look at it just like you did as well, and I like the way you've answered the first question. I'm not criticising it by any means. It's absolutely fine. You got the answer, I think, right, didn't you? I'm just looking at this. Yes, you did, yeah, and you've done it in a very sensible way. So I'm going to look at the x component first and do v squared is u squared plus 2as. So I get lambda squared, v squared is u squared, well, that's 9 squared, plus 2 times 0. Times by sx. Okay, so I've used all the x components, so I'm doing this, if you like, in your notation, this is lefty righties, yeah? Okay, and that just gives me, because that's 0, that just disappears, and I get lambda is 9, yeah? Now, that's lovely, yeah? Firstly, I know it's a positive constant, and that's why I don't have to worry about minus 9. I'm now going to do exactly the same with the y components. I'm going to do v squared is u squared plus 2as, but with the y components. So I get minus lambda all squared, which is lambda squared, is u squared, which is 144, because it's 12 squared, minus 2gh this time, yeah? Okay, but I know lambda is 9, so that's 81 is 144 minus 2gh, and so just like you, I end up with h equals 3.2. Quick point about your answers, it's written down, you've written it down to 8 decimal places. That'll actually cost you the accuracy mark for that, because they want it always to 3 sig fig. 2 or 3 sig fig. I think on the applied paper they say 2 or 3 sig fig, or they might say 3 sig fig. Look on the front of the paper would be my advice. It's a really good thing to do. Okay, part B. Now this is where it gets weird, isn't it? Because it wants minimum speed here, and then part C where you're stuck, the length of time for which the speed of the ball is less than that, yeah? That's really weird, isn't it? That's kind of a tricky question. So, right, well, let's try and find out. Okay, so I suppose, and for time for which, let's do B first. The minimum speed of the ball as it moves from O to A. Now A, where is A? Ball pass point A. Oh, it's at H meters, yeah. So A is on its way down, yeah, and I've realised it's not on its way up. I couldn't see your diagram, but because it's definitely on its way down, because I was saying about the velocity being at 45 degrees. So this is the point A, is it there? Okay, right. So yeah, okay, right. The minimum speed of the ball as it moves from O to A. The minimum speed is going to occur when the component of the velocity in the up and down direction is 0, yeah? In the left and right direction, the component of the velocity doesn't change, does it? It's always 9. In the up and down direction, the component of the velocity does change. It's initially 12, but then it's reducing by 9.8 every second. So after a second and a bit, it reaches its maximum height. And at that point, the velocity vector, not this one, yeah, this one's at A, this one only relates to A. The velocity vector at the top, at the peak, would be 9, 0, yeah? So, I mean, if I was doing this in exam conditions, especially because it just said to write down, I'd say at the peak, yeah, the, you know, for, let's just put it like this, for V, the velocity vector, Vx, Vy, yeah, I just point out Vy equals 0, and Vx is always 9, just because it started off as 9. And so, the maximum speed, or minimum speed, sorry, minimum speed is 9. I hope that makes sense as well, the way I've done it there. I've kind of done it quite casually in my head. It might be possible, though, if I do the next one in a bit more of a... well, because the next one's a bit harder. If I do it in a similar way to Part C, I'll show you another way you could do Part B in a bit more of a systematic way. Okay, right. Find the length of time for which the speed of the ball is less than 12 meters per second. Well, my first thoughts are, I really need to find then how long it takes to get from O to A, and then I can subtract from that the length of time for which the speed of the ball is less than 12 meters per second. Yeah, I know, actually, thinking about it, I know that it's probably going to be up to here it's greater than 12 meters per second, then it's going to be less than 12, then it's 9 right at the top. And what was the velocity actually when you get to A? Let's talk about the speed, sorry, when you get to A. Let's quickly work that out, because that might be useful. At A, the speed is, well, we worked this out as 9 minus 9, didn't we? And if you do the square root of 9 squared plus 9 squared, that's the square root of 162, which is like 9 root 2. And I'm trying not to use a calculator, but clearly 9 root 2. Okay, what have we got here? Let's say, I'll put 9 root 12. I'm so bad with a calculator, I'm sorry. 9 root 2 is like 12.7 meters per second, yeah? So if we're looking for when the speed is less than 12 meters per second, it's going to happen like for a period of time, like around here basically. And there's going to be like a T1 and a T2 for when the speed is less than 12, and it's greater than 12 here, and it's greater than 12 on the way down. But anyway, let's talk about how we're going to solve this. My approach, you know, I haven't seen this before. I'm doing this live. I'm kind of thinking, well, I really would like to be able to write down V, yeah, in terms of T, yeah, because obviously I'm interested in the time, yeah. So this is like a V equals U plus AT problem. Now remember, U is still 9, 12, yeah. A is still 0 minus G, yeah. Now V is kind of what I'm interested in here, yeah. Let's call it like Vx, Vy, yeah, and then T equals T, yeah. That's what I'm going to do, yeah. Cool. Yeah, I don't need to worry about H till here. Right, what I'm going to point out is that like speed is Vx squared plus Vy squared square rooted. Yeah? Okay, and here V equals U plus AT. So what I could do is I could write down V as, instead of writing down as Vx and Vy, let me write it down as U, 9, plus AT plus 0 times T. Well, that's just going to be 9. In other words, the velocity is always 9 in the x direction. I said that earlier as well, didn't I? In the x direction, the velocity is always 9. In the y direction, it's going to be 12 minus gt. Yeah? And remember, g isn't an unknown here. All I need to do is to make sure that this is definitely, after I've squared the 9 and squared the 12 minus gt, and then added them together and then square rooted, I need to make sure that this is, what is it, less than 12? So I want this to be less than 12. Yeah? So I'm just going to set it up like that as an equation. So what am I going to get? I'm going to get, firstly I'll square that over there. So I get 9 squared plus 12 minus gt squared, and that needs to be less than 144. Now this is looking suspiciously like a quadratic inequality. That's what it's looking like to me. Let's multiply it out. We get 81 plus 144 minus 2 times 12 times gt, so that's going to be minus 24 gt, plus g squared t squared is less than 144. And so now I'm going to bundle everything on one side so it's a much more recognisable quadratic g squared t squared minus 24 gt. The 144 here is going to cancel with 144 here, and we're going to have a plus 81 on the end is less than 0. Okay, this is one of those things where essentially you're dealing with a positive quadratic and you want it to be less than 0, and basically between 2 times it's going to be less than 0, and so that's why you're going to end up with like t is trapped between 2 times, and if you subtract those 2 times, in fact you might even prefer, perhaps you prefer to look at it like this. I think I'm suddenly preferring to look at it like this. If I make that inequality sign, just because it's introducing confusion, turn it into an equal sign, let's find the times when you're going at 12 meters per second, and if we subtract them between those times, you'll be going at less than 12 meters per second. For the same reason I was waffling up here, you know, that's when you get 12 meters per second, then you slow down under it, and then you're going to get 12 meters per second again. Okay, so now it's just basically a quadratic which we have to solve. Annoyingly, I haven't got my good calculator here. I wonder if I can just look up online a quadratic solver, because I can't be bothered to do it with a formula. Quadratic solver. You obviously can use your quadratic solver on your calculator. Here we go. Here's a quadratic solver, is it? I've got it on the other screen. Don't worry if you can't see it. It's not. I just want a simple quadratic equation solver. Oh, good, here we go. Okay, A is going to be, what is that, 9.8 squared. I'm going to have to do this. 9.8 squared. I've got the worst calculator in the world at the moment. 96.04. Sorry, it's taking me a little bit of a while. This is what happens when you lend your calculator to a student. Minus 24 times 9.8, so 24 times negative 0.9, well, times 9.8. Okay, minus 235.2. It's a hard question, this, by the way. I don't think it's easy. And then 81 on the end. Okay, solve. Okay, it is saying here 2.03. I get two answers. This is what you should get on your calculator, probably a bit quicker. 0.41457, and I'm like you, I work to a few sig figs until I get to the end, and then I round it to 2.03441. Okay, subtract times, and I get, okay, let's quickly subtract those. 2.034 minus 0.4145. Okay. Basically getting 1.62 seconds. I'd probably round that to, if I had the choice, to 2 sig fig as well, because I think I've been quite slapdash. Okay, hopefully that gives you the correct answer. Yeah, I think it's the same as in the mark scheme. Hope it makes sense as well. That's the most important thing. So all I've done is I've set up the velocity as a vector, and I've found the length of that vector. I need the length of that vector to be 12. That's all I'm really doing. Okay, the model could be refined by considering air resistance. They're sick of hearing air resistance as an answer, so they say basically don't use air resistance. And another way you could do it is you shouldn't be treating the object as a particle. It should have dimension. There's other things you could consider as well, like the spin or something like that. There's various answers that allow for that. Okay, velocity time graphs. This is the next question. Now, car moves along a straight horizontal road. Let's start drawing this, because I know I've got to draw the diagram out. And I don't think you had a problem with this bit, because the diagram's quite nice, more or less, but be careful on it still. It's accelerating basically for 30 seconds, and it's constant, so it's a straight line, before reaching a speed of 15 meters per second. The speed is then maintained, so 2 tools along. When the car's been moving for 15 seconds, they like these questions as well. There's some good examples in the old Red Rayner textbook for this. Starts from rest at A and moves along the same road as the direction of the car. Motorbike accelerates at 1.5 meters per second, so it catches up with the car when it's been moving for t seconds. Okay, it catches up with the car. That's interesting. Yeah, if it catches up with the car, then at some point, at the same time, they would have travelled the same distance. So what we're saying here on this diagram is that the area of that triangle there is going to be equal to the area of the trapezium here at time t. Yeah, that's what's genuinely happening here. Okay, so I hope that kind of makes sense. That's how I'm going to model this problem. Okay, so let's start working on it. Okay, Sorry, I just got distracted then, my phone was ringing. So find the speed of the motorbike at the instant it catches up with a car. So in other words, we want to know this v. Yeah, that's what we want to know. It's got some kind of speed when it catches up with a car. It doesn't catch up at this point. Sometimes people think when they intersect it's caught up. No, that's not true. It hasn't caught up. That is not what's happening here. Okay, so let's do it. We know that this area is the same area as this area. Yeah. So what I'm going to say is I'm going to say, well, firstly, I'm going to say here. Do I know anything else? Have I missed anything here? Oh yeah, I do know the I didn't write this down on my diagram. The motorbike accelerates at 1.5 meters per second, which means I know that gradient is 1.5, and that means I can find v, yeah, or I can find v in terms of t anyway. Yeah, it's an interesting one because it means I'll have two equations, two unknowns. Yeah, because if that gradient's 1.5, well, what I can do is I can say now gradient's worked out by rise over run. The rise is v. The run would be like t minus 15, yeah? So that gives me an equation which is 1.5 times t minus 15 equals v. Okay, that's one equation. I've got two unknowns, so I need another equation. What's the other equation I can find? Well, it's this trapezium here. I can say that this is the same as in this trapezium. Actually, I can solve to find. Well, no, actually, I can't. I'll need to bear this in mind. Yeah. Now, I'm now going to match the areas up because that's what I need to do. Yeah, I've got to match the areas up. What I could do here, I suppose, with that is, yeah, there's nothing. Can I just check as well? Yeah. I've sort of rushed through this slightly. When the car's been moving for 15 seconds. Yeah, that's cool. No, this is cool. Yeah, it's quite a tricky question. Okay, so what I'm going to do is I'm now going to find the area of the triangle. The area of the triangle should be equal to the area of the trapezium. Can I write that down first? Area of triangle equals area of trapezium. Okay, how do we work out the area of a triangle? It's going to be t minus 15 times by the height, which is v, yeah, and then I'm going to divide it by 2, yeah. The area of the trapezium is going to be, now there's loads of ways of doing this, but I think what I prefer to do is treat it as a trapezium, yeah. That distance from there to there, now can I just check I'm using, the motorbike accelerates at 1.5, so it catches up with the car when the car has been moving for t seconds. Good, yeah, I have got the t right here. I want to know if the distance from there to there is t, or if the distance from 0 up to here is t, and it's from 0 up to t, because the car starts from rest, and so that distance is t. Good, everything's right. Okay, so area of the trapezium, I'm going to do the height, which is 15 over 2, and then I'm going to do this distance, which is t, plus this distance, which is t minus 30. Yeah. Okay, so I've got two equations and two unknowns essentially, and I've just got to solve them. So let's solve them. I'm going to double both sides to get rid of the 2's, and I'm going to keep this as t minus 15 actually times v, and then this is going to be 15 times 2t minus 30. Yeah. Okay, cool. And then really I'm thinking, well, what do I want to get rid of? Ideally I want to get rid of the t's, but it might be easier actually to just plug this in here, find t, and then hence find v. I was thinking at first, should I get rid of, because I need to find v here, should I get rid of t minus 15 by plugging it as v over 1.5? But then I've got to get rid of this t over here as well, so I'm not really up for that. I'm just going to plug this in here as t minus 15 times 1.5. So I'm going to have t minus 15 squared times 1.5 equals 15 times by 2t minus 30. But when I'm rearranging this, I realise I've actually got, if I take out a 2 from here, I'm going to have 30 times t minus 15. This is a kind of crafty move here. Is t minus 15 squared times 1.5. Well, look at this. I can actually divide by t minus 15 because I know t isn't 15 because that would imply a contradiction there at the start of it. So I'm going to safely divide by t minus 15 to get t minus 15 equals 30 divided by 1.5, which is 20, and so t is 35. And if t is 35, you'll have 35 minus 15, which is 20. 20 times 1.5, so v is 30. And I'm just going to frantically check your answer here and check that I've got it right. Did I get it right? Yeah, 30. Okay, I've probably done it very differently to the mark scheme. If you ask me to do it again next week, I'll probably do it differently again. I find I kind of like make those ones up in my head as I go. Key thing is though, just look at the features that you've got, yeah, and try and write down all the information and gradually solve it as you can. But I agree though, mate, those are both quite tricky, awkward questions for mechanics, so well done. Find me some more, find me some tough questions. I don't mind what the topic is. Okay, thanks for listening and bye bye.